It is. Yes, finally. It's been gloomy. All right, guys, so let's take out that practice test A. Hopefully you've done that. If not, again, you're putting yourself in a bad spot. The more you can get practice and learn from your mistakes, the better off you're going to be. I can't emphasize that enough. Even if you kind of feel a little sketchy about yourself right now, just having done this and me going over it, I can kind of translate that for you a little bit and maybe project your score out, even with just one section. Although ideally, when we get through with all four of them, obviously you'll have a better idea. Yep.
Do you have any extras? Because I realize I lost one.
I probably do.
Totally, definitely.
This was test A.
Thank you.
Yep. Just lost that. All right, so in an effort to make this better, I've got the key. I'm just going to run through the actual solutions with you quickly, and then the answers, and then we can look at it. You got yours? Get it out. We'll look at it. Come on. 1 is D. All right, so 1 is D, 2 is B, 3 is B, 4 is E, 5 is D, 6 is B, 7 is C, 8 is C, 9 is D, 10 is A, 11 is D, D is in dog, 12 is E, 13 is E, 14 is A, 15 is C, 16 is D, as in dog, 17 is B, 18 is B, 19 is B, 20 is D, as in dog, 21 is A, 22 is E, 23 is B, 24 is A, 25 is C, 26 is E, 27 is D, and 28 is B. And if you take the number that you got right and multiply that by 1.2, all right, let me think for 1 second. And then, okay, so if you take the number you get right, let me make sure about this, and multiply that by 1.38. Try that. And then multiply by 1.2. And then double it.
Wait, can you say that all over?
Okay. So take the number correct times, it's going to be better when we do the next part, but I'm a little sketchy. Multiply by 1.38, and then by 1.2 points, and then double it. This is going to be very rough. Do that, and then somebody tell me what you got. Feels about right. What do you got?
89.
Oh, I was just going to ask what, I didn't hear 2 or 3 answers.
Okay, we'll go back. Oh, well, just go ahead and ask me. Which ones?
It was B.
B and A,
No, wait, I didn't get 3.
Which ones, Carla?
2 and 3.
Oh, 2 and 3. I just meant 2 or 3 questions. Sorry. 2 is B and 3 is B.
Can we look at number 20?
20, can we do it, number 20? Absolutely, we can do all these, we got time today. Anybody else get a number?
19.
No, anybody else want to throw a value out there?
So that was my number.
Seeing if I'm right on this.
What are you trying to calculate?
You would need 6 questions right.
Okay, so there's, I may be wrong about this, if not, my regular math skills are struggling. So this represents 0.62 of your multiple choice. So there's another 0.38 that's going to count on this as well. So this may be off. I'm just, again, it's Monday. We'll know that after you take test B tonight when we grade that tomorrow, okay? And that represents half the test. And then each of these problems are worth 1.2 points. So this part basically approximated what would happen to you after if you continued on this pattern through the rest of the test. That makes sense? Through the rest of the multiple choice part. And then if you get this much amount on your free response, which is not necessarily guaranteed. Most people that do poorly do better on the multiple choice. Most people who do really well do better on the free response or the same on the free response. So people that make 5s and 4s tend to do the same or better on the free response because they really, really get it. People that tend to not do so well at all, like 2s or 3s, definitely do better on the multiple choice because there's guessing involved and free responses tend to be a little ugly. But again, this first test, who knows what's going to happen. But if you're in the 70s or the 80s on this, heck, if you're in the 50s or above based on this right here, then that bodes well for you. If you're not, then it still could bode well if you continue to improve. So I've got this thing pulled up. Let me, let's take a look. Where am I? There it is. Okay, so any question you have, let's take a look at it. We can slowly scroll through all of them. There's 28. We should have time to get done in class. If you want to go through all of them, look at number 1. It says find the limit. Remember, I did not evaluate this limit by looking at it and saying, oh, I need to factor. I evaluated my limit by plugging it in, seeing what happened. And when I plugged the 2 in, I got 0 over 0. I didn't show that part, but that is always what I do on a limit to a value. Always plug it in and let the answer be an indicator to you. And because I got 0 over 0, I said, well, 0 over 0 means there's a hole, most likely. Let me factor it and cancel junk out. Now, if you stink at factoring, you've got an option. Your other option is L'Hopital's rule. Remember, if you get 0 over 0, you can take the derivative of the top, the derivative of the bottom, and then redo the limit. So if I were to take the derivative of this, I get 2x plus 1. On the top, on the bottom, I get 2x. And when I plug the 2 back in there, I get 4 plus 1 is 5 over 4. So had I done L'Hopital's rule, which I did not show the work to this here, I could have gotten this as well. And by the way, also, a different way. Also, I did this key like 8 years ago. I think I'm a little better at calculus than I was 8 years ago. So some of my methods might not necessarily be the best, but it's what I was thinking then. And I don't redo all 15 AP tests keys every year to add to my knowledge base of results. So some of these I might look at and go, why did I do that? But just know that's because I did this key a long time ago. Number 2, it says find the derivative at 2. Now again, on a multiple choice question, guys, you don't have to show your work. But on an AP test, make sure you show your work. Like literally label it. I mean, on the free response part, label it as F prime. Okay? Label it with the derivative and then show F prime of 2 with the 2 plugged in. Make sure you are doing that because AP, and if you don't label it as F prime and just write this, you probably are not going to get that point if it's a free response question. Okay? So make sure you're labeling stuff. So I just took the derivative using the power rule, plug the number in. And usually your first couple questions are going to be pretty basic like this. Number 3, which of the following definite integrals has the same value of this? I'm willing to bet a ton of you missed this. Am I right? Okay, we have never done a question like this, and AP puts it on there all the time. I missed it my first year, which stunk because it was the only question I missed on this, and I've never done one perfectly, and this would have been an easy one to do perfectly. But on this, I bet a lot of you had, what, A?
Yeah.
Okay, so if you had A, that's not your fault. That's me not showing you this problem. The way you guys have learned U substitution, right, is to do the U substitution, right? Rewrite it, take the integral, and then what? Put the U back in, right? And when you put the U back in, it allows you to still use 0 to 4. But this question said, which of the integrals gives me the same answer as that? So what you guys did is you guys did U substitution and got this, right? But the problem is this answer right here, if you just looked at that and I said, hey, evaluate that integral, there is no U to plug back in, is there? Like if I just gave you this right here on its own, you would go, oh, the integral of e to the U is e to the U. Tack on 1/2, plug the 4 in. That's what you would have done, right? They want you to answer the question, which of these is exactly the same on its own, just sitting there by itself? So what it means is, because we're actually not going to do the integral, in this process right here, where you substitute U in there, and then the du in there, you would have gotten this, right? Well, they want you to change everything. Don't just rewrite that and that in terms of U, but rewrite the 0 and the 4. So what they want you to basically do is say, well, if the original x values were 0 and 4, and you're changing x to U, then change those values to U values as well. So you go, well, if x is 4 and U is x squared, then change that 4 to a 16, 4 squared. If x is 0 and x squared is U, change that to U is 0 and use 0 to 16. Now, this right here, this problem right there, now has the exact same answer that you get if you used B. But if I just handed you that question, you would have ended up with 1/2 e, that's a U right there, e to the 4th minus e to the 0. That's what you would have ended up with. But what you should have ended up with, if you had done this on your own, you would have gotten 1/2 e to the 16th minus e to the 0, wouldn't you? So you have to change this. This problem is kind of unique, and some people do a complete U substitution on every problem. Most people don't. Books don't. What books do is they do the integral, and then they do what? They plug the U value back in, right? You plug the x squared back in when you are done, and then you don't have to change the bounds on your integral. They're asking you to change the bounds as well. Are you seeing that? Expect to see one of these on every single AP test you ever take. So the more you see them, the better off you're going to be. But most people don't teach this. The AP throws it out that way, and they do it every year. I've never seen one other than last year, which is just a short mini version. I can't say never. I have no memory of having a test that didn't have something like this on there. Y'all with me on that?
So in terms of being able to recognize when it's like that and it's different, is it just going to be when the answer choices are?
Yes.
Are
See, if they had the answers here, it wouldn't have mattered, right? Because you would have plugged it back in there. But when they say, hey, which of these definite integrals is just like that, you're like, oh, I need to change the 0 and the 4 as well. Y'all seen that? And you could do that every time. Like you could do it every time. You could say, all right, U is that, du is that, there's my U, there's my du. I need a 2, I need a 1/2, and you get this 1/2, 0 to 4. This is what you probably are used to doing. And then say, wait, I forgot to change that and that. So plug the 0 in there, U is 0. Plug the 4 in there, U is 16. And if you do this, you never have to plug the U back in, ever. And that's something you could have done each and every time. But most books don't teach it. Most colleges don't teach it that way, and that's why we don't. But AP throws a one problem a year on there just for those people, just to kind of check and make sure you understand that unless you plug the u back in, you would have to modify those bounds as well, right? All right, so that right there is 1.2 points you're going to get back based on this score. Okay, number 4. Which of the following is an equation of a line tangent to that? I told you they were going to ask the crud out of that question. So what do you need if you need a tangent line? A point and a slope. They gave you the point. Merry Christmas. So now you need a slope. And how do you take the slope of something that's got a bunch of x's and y's mixed in together? Implicit differentiation. So literally, I've got an x squared, I got a negative 3xy, and I got a 10. So the derivative of the x squared, pretty easy, 2x. Technically, 2x times dx, but don't have to bother. And then I have a negative 3xy. And what was my encouragement to you? If there's a negative on there, group that negative with the 3 and the first variable, right? And then group the second variable. So I did first negative 3x times the derivative of y, 1 dy dx, plus second, which is the regular y, times the derivative of the first, which is negative 3. Y'all seeing that? I didn't write it in that order, but this is me going first, d second, and then derivative of the then second d first. First d second plus second d first. I just wrote it in that order. And then the derivative of the 10 is 0. And then if I want the equation of the tangent line, I need what? What do I need? The slope at that point. So if you wanted to, you don't have to solve for dy dx and then plug the point in. You could have just plugged the point in right now and solved for dy dx. So if I wanted to, I could plug 1 in for x right there. I could plug 1 in for x right there. And I could plug negative 3 in for y right there. And that would give me 2, I'm going to go up, 2 minus 3 dy dx plus 9 equals 0. And I could subtract the 9, subtract the 2, which gives me negative 11, divide by negative 3, and I get 11 thirds. And then I can take that point, that 11 thirds, and that slope, and plug it into point slope form. And a lot of times I'll have it solved for y equals. So if that's the case, distribute it. But I always go into that, and a lot of times I have it in the point slope. So here's a case where I went through the mess of this, but I don't know that I would have done that moving forward. Y'all with me? Stop me any point. Number 5, if g is a function given by that polynomial equation, where is g decreasing? So where is the function decrease? When its derivative is negative, right? So if the derivative is negative, I need the derivative. So I take the derivative of this guy using the power rule, and I get that. Pretty nice, simple function. And then I need to find out where that's negative. So I take that, set it equal to 0 to find the critical numbers. So I got to factor it, set it equal to 0, and I get negative 10 and 7. And then that's where the derivative is 0. Now I want to find out where it's actually negative. So I check values in between there in the derivative, right? Because I want to know the derivative values. And I plugged in like negative 11, 0, and 8, because those are the smallest numbers, are the ones that were easiest in the intervals. And then when I plug that in there, I can plug it in there if I want, but I don't like that. If I plug it in there, I get a negative times a negative, which is positive. So it must be increasing there, the derivative. The function. And I plug a 0 in there, and I got a positive times a negative. So the function must be decreasing there. And then I plugged an 8 in there, and I got a positive times a positive. So the function must be increasing there. So over the interval negative 10 to 7, you can see that right here. And really, they gave you the options that are most likely, right? Negative infinity, negative 10, 7 to infinity, negative 10 to 7. And then they had a bunch of weird bogus ones in there. But A and D would be the increasing and decreasing intervals. D was decreasing. Remember that? Digging way back for this one. Number 6. Number 6 was evaluate the integral. So you can see on this one, of course, I need a u substitution. The key for me on this one was if I take the derivative of this linear part on the bottom, I get a constant, so that's easily fixable. So u is that, du is that. I made my substitutions, put the negative 3 and negative 1/3 in there, circled the parts, rewrote it, and I noticed I did not change the 2 and the 4, did I? Why? Because I just had an answer here. But like Sam mentioned, if I had a different integral there, then I would replace 2 with what? Can you see it? I would plug 2 as an x value based on the x equation. I'd plug 2 in there, and I'd get 5 minus 6. I'd replace that with a negative 1. And then I'd replace 4 with 5 minus 12, which would be a negative 7. And you can do that if you want. If you do, then you never plug the 5 minus 3x back in. Just never do that. Because that 5 minus 3x, plugging it back in, look, plug the 2 in there, there's your negative 1. Plug your 4 in there, there's your negative 7. So that was another way of doing it, but because I just have regular answers, I stick to the way I've always integrated, which is integrate, plug the u back in, and once I plug it back in, I can use the original 2 and 4. So I plug the 4 in, plug that in. This is why you gotta be careful about absolute value. If I forgot the absolute value, this doesn't exist. But with absolute value, it makes it natural log of 7. And you know the natural log of 1 is 0, right? So you gotta know a little log stuff, not a ton, but a little. So you end up getting just a negative 1/3 natural log 7. And they just put the 3 in the bottom and the negative out front to annoy you. All right? So you got to know U substitution. Listen, it's not going to be groundbreaking U substitution, but there is some U substitution. Number 7, let the function be given by that. What is the instantaneous rate of change? What's instantaneous rate of change mean? What's the derivative? At 3. So I took the derivative using a power rule. I showed that. I labeled that. Even though I don't need to on a multiple choice, build good habits. Then I take the derivative at 3, and I got a negative 1. So if you can do 1 through 7, you probably should be able to do 1 through 7 pretty easily. If not now, definitely by the end, you are rocking, you're on your way. This one, okay, a particle moves along a straight line. The graph of the velocity at time t is shown in this picture. And the picture was really just going up and then down and then back up. Okay, I added in this other part, which I'll explain in a second. It says over the time interval from 0 to m, this being m, that they showed you right there. It says j, k, l, and m are constants. And the graph intersects the horizontal axis at 0, at k, and at m, and has horizontal tangent lines at j and at l, which are at the high and the low spots. For what values of t is the speed decreasing? Now, again, they introduce speed. What do you know about speed and its relationship to velocity? It's either the absolute value of velocity, which is why I took this and flipped it up, right? And if you do that, and then the question is, where is speed decreasing? This is the speed graph. Where is it getting smaller? Bam, bam. So from JK, from L to M. And that is probably the easiest way to think about it. If you recognize that absolute value of a function just flips all the negative parts up. And you want to sketch that, knock it out. But what else do you know about speed? Speed decreases when what? You got to know this. When the signs of velocity and acceleration are, it's decreasing when they're opposite, right? So it speeds up or increases when they're the same. It goes down or it slows down or decreases when they are different. So think about it. Where is velocity positive and negative? Velocity is positive where? So that's positive velocity. And then this is what? Negative velocity. But what's acceleration? Slope of velocity. So acceleration is positive where? Where you have positive slopes. Acceleration is negative where you have negative slopes. So positive acceleration, negative acceleration, more negative acceleration, and then positive acceleration. So where do you have the same signs? Where do you have different signs? Here to there, and where? Here to there. But if you can remember the absolute value thing, and you have a graph of it, I think it makes it a lot easier. Does that make sense? And they'll certainly ask you ways where you don't have the graph of it and you can't just make it positive. All right, so what about number 9? Let f be that function for which of the following values of x is f not continuous? Now, when is something not continuous? Holes, VAs. Now, there are other things like jumps and junk like that, but does this graph, does a regular function, can you even have a jump? This is a rational function. Rational functions are like polynomials in most ways. They go forever to the left, forever to the right, and the only place they have breaks are what? Holes and VAs. So what does this thing have? Holes and VAs. So bottom line, the only places you have to worry about are denominators that are undefined, like 2 and -1. So this is a pre-calc question, if you ask me, right? I didn't even have to identify which one was the hole. And there is a hole right there where the x minus 2's cancel, right? And there's a VA right there at -1 where there was a non-canceling factor. But bottom line, it was undefined in a couple spots. And if it's undefined on a rational function, then that's the only place it's going to not be continuous. All right, number 10. Particle moves along the x-axis with that velocity. If the particle is at position x equals -2 at time 0, what's the position of the particle at time 3? So how do I go from velocity back to position? I integrate it, right? You take the derivative to go from position to velocity or velocity to acceleration. You got to integrate to go back. So I've got to integrate this velocity function, right? And then when I do that, what does it give me? C. So this is now my position function at some constant. But I need to find that constant. So how do I find the constant? I use what? I know that the position is -2 when t is 0. So if I plug a t equals 0s in there, that means my position is -2. So -2 equals 0 minus 0 plus c, and now I have my c value. And once I have that, I'm home free, right? Once I have that, I can go, well, now I can just plug a 3 in and find the position then. Now that's using very early calculus. The second way to do that is to use your fundamental theorem. And your fundamental theorem says, and I could write it a couple ways. I'm going to write it this way, which says the change in position plus the initial position is your final position. And since I knew what happened at 0, and I want to know what happens at 3, I use 0 to 3, x0, x3. And I know x0. x0 is -2. I can integrate that. And I didn't show my work, but I could do it, right? And then plug in the 3 and plug in the 0 and subtract them. That gives me this, and then I add them together and I get that. So you may look at it and go, oh, well, this is much less work. No, I would have still had to integrate, but when I integrated, I would have gotten t cubed right here, minus 4t. I would have gotten the same thing from 0 to 3, and I would plug the 3 in there and get 15. I plug the 0 in there and get 0, and there's my 15. Y'all seen that? So this is the fundamental theorem. It's the same thing. I keep hearing you guys or my 6th period class go, well, I didn't do it that. I did it this way. It was easier. Well, that's the way I did it my first couple of years too. And then when I got more and more comfortable with fundamental theorem, I was like, well, if I know values or want to know values at 2 places, I can use the fundamental theorem. And remember, another way to write the fundamental theorem is what? Is not putting that over here and saying that is x3 minus x0, right? Only thing I did different was just added the x0 to the other side. But this is the change in your position, right? This is change in position. If I add it over, it is final position is change plus initial. Y'all seeing that? That's the most rusty thing you as a class and the other class as a class. Most rusty thing that's going on right now is not thinking this way, but trying to think this way. And I'm seeing it on your tests over and over. So hopefully in the next month, we'll get a month and a week or don't let anything bother you. Where is the function concave down? Where its second derivative is negative. So if this is the function, how do I find second derivative? I'd have to take the derivative of it twice, right? So what happens when I take the first d dx. Oh, what does that look like? What's that? Second fundamental theorem. And what does the second fundamental theorem say when you d dx an integral? What do you do with that 0? Or any number that's down there? Can it? Ignore it. And what do you do when it's an x? You plug it in and then take the derivative of the x, which in this case is 1. So when I plug it in there, that tells me the derivative of x is just that stuff. But I didn't want to know that, did I? What did I want to know? Second derivative. So then I take the second derivative of that. That gives me f double prime. And what is that equal to? 6t squared minus 30t plus 36. And that's where I am right here. So this is just me applying my second fundamental theorem. And now I want to know where the second derivative is negative. So how do I find out where that second derivative is negative? First, find out where it's 0. So I set it equal to 0. By the way, always say that. Don't just start factoring. You get a point for setting it equal to 0 in most cases, even when you don't know how to factor correctly. Just for acknowledging that. So I'm going to set the second derivative at part equal to 0. Right? Factor, I like to divide the 6 out. It made it look better. And then factored it, set those factors on a number line, check the second derivative. And I found out it was concave down between 2 and 3. And again, I'm just plugging that number into these factored parts. To me, it's easier instead of plugging it up in here and actually having to calculate. Tracking with me? All right. Now, hopefully all of this is starting to seem pretty familiar or felt pretty familiar. Here and we are almost at the halfway point. Number 12. For which of the following does that limit of a function equal 0 as you go to infinity? Now, when does a function equal 0 when you're dealing with fractions? When we talked about this actually in pre-cal today. If you have a fraction and you're going to infinity, when is that fraction going to approach 0? When the denominator is a higher power or growing faster? So what do you got here? What grows faster? Natural log functions or polynomial or powered functions? Powered, because natural logs do what? They keep growing, but they kind of flatten out, don't they? They're actually growing really slowly. Whereas x to the 99th, that's shooting up, right? So yeah, this is growing way faster. So that's approaching 0. And then right here, what grows faster? An exponential function over a natural log? Exponential. In fact, the answer to exponential function over anything else, the exponential grows faster, with the exception of maybe a more powerful exponential function. So top's growing faster. Well, that's not going to 0, isn't it? That's getting bigger. And then on the bottom, you got a powered function over an e to the x. What grows faster? That's an awfully big power. Still the exponential. Now, if you did L'Hopital's rule, because remember, you can do L'Hopital's. If I plug an infinity in there, I get infinity over infinity. If I do that along with 0 over 0, I can do L'Hopital's. What happens every time I do a L'Hopital's? 99x to the 98. 99 times 98, x to the 97. If you keep doing that enough, what's going to happen? X to 98, x to 97, x to 96. You're eventually going to get a constant, aren't you? Which is not growing at all. But the bottom is still going to be e to the x. Right? So powered functions with L'Hopital's eventually become constants if you keep doing L'Hopital's rule long enough. And constants on the top, growth on the bottom, that's going to 0. Man. But hopefully you won't have to do that. Hopefully you'll just go, oh, exponential goes fast. So 1 and 3. All right, number 13. Let f be differentiable such that blah and blah for all x of the following, which is not possible. Okay, these kind of problems, guys, draw pictures. So what does this mean right here? What is that giving you? If I say f of 0 is -5, I'm giving you a point. Plot it. So at 0, I'm down here at -5. And now this says what? The derivative is what? Smaller than or equal to 3 for every value of x. So the derivative is either going to be 3 or smaller. So if it were, and then it says, of which of the following is not a possible value of f of 2? Well, if I'm starting right here and my slope could be as big as 3, then what happens by the time I get over here to 2? What has it done? It could go rise 3, run 1, rise 3, run 1 twice. And I could be as high as what? 1. So if I can get up to 1, and that's the biggest I can possibly be, could I ever be at 2? No. But I could totally be at these values. Look, if I went, the slope can be negative, right? As long as it says smaller than or equal to 3. I could be all kinds of negatives. So the biggest I could be right here is at 1, not there. So anything there or smaller, certainly 0 is an option, certainly positive 1 is an option, certainly -5 and -10 are options. Are y'all kind of seeing that?
I
Now-
guess in that case where you're looking for what it can be, and you know it can be like in probably large, isn't it always just gonna be the biggest one there?
Yeah, for something like smaller than or equal to. Yeah, it could be greater than or equal to. But yeah, I don't know why this is much of a calculus problem. To me, it's more of a, do you understand what that means and what that means? But draw a picture of these. When they start giving you these values, visualize them. It helps a lot better. But this shouldn't be overall in the whole scheme of things that taxing, especially not in 5 weeks. All right, number 14, you've probably seen this a half dozen times from last year and this year. It says, here's a function. It's a piecewise function. What do the two parts look like? This is a line. Looks like a line because b is a constant. And this is a parabola. And then evidently at 1, they go from linear to quadratic. So I don't know if they connect or not at 1. Let's see what it's asking. From this function, which values of a and b would f be differentiable? Okay, now you got to be careful about differentiable. What does differentiable mean? That it's not only continuous, but what? The slopes are always the same from the left and the right. All right? Which means I can't have any what? Corners happening. Now, I know that linear functions are always differentiable. They're lines. They always have a slope, nice and smooth. And I know that quadratics are always differentiable, right? Slopes are always the same. They're nice and continuous. They have no corners, no cusps. But I don't know at +1 whether this line joins in with this parabola nicely. But it's saying find a and b so that they do. The biggest mistake people make on these is they go, well, let me create a derivative function. The derivative function here would just be 1 because the derivative of x plus a constant is 1. And the derivative here would be what? 2ax, right? 2a times x to the first. So they do this. And all they do is check this. And they plug a 1 in and they assume everything's going to be okay. But the big mistake is this graph might not even exist at 1. Make sure it exists there first. Make sure that it actually has a value there because it has to be continuous and differentiable. But it does have a value, right? The value you get is what? If I plug a 1 in, I get 1 plus b. If I plug a 1 in there, I get what? 1a. So these would have to be the same to be continuous, right? And then over here, if I plug a 1 in, I get what? 1. Plug a 1 in there, I get 2a, right? 1 and 2a. And with those two equations, I can solve for a and b. Y'all seeing that? So I'm making sure they're continuous, right? The limit exists, the value exists, and they're equal. And then I'm checking the derivative from the left and the right, make sure the slopes are the same. And if the slopes are the same and it's continuous, then it's differentiable. So I solve that a for 1/2, plug the 1/2 in there, and I get b is a -1/2, and I'm good to go. And the other thing I guess you could do is just guess, check, and revise. You guess, check, and revise. You might see that as well. Just pick these answers and plug them in and see which ones make sense to you. But that would be the way you do it if you couldn't guess, check, and revise. Yep. Yes. Just want me to jump right there?
I mean, you can keep going through.
Give me at the 2-minute mark. Tell me and I'll jump there if we're not there. 15. The table above gives the values for f and g and their derivatives. Let k be a function given by that. What's the value of k prime? Don't let this stuff freak you out. If I want to know k prime, I want to know the derivative of that. How do you take a derivative of a fraction? Low d high minus high d low over low squared. Low d high minus high d low over low squared. 99% of you got that right. There are a couple of you went high d low minus low d high over low squared. Make sure you don't do that. There are a couple of you that forgot the low squared. I think you know that, but I think maybe it was careless. But anyway, at this point, I'm just plugging in 3. So I'm literally going, I want g of 3, f prime of 3, f of 3, g prime of 3, g of 3 squared, and I'm just using my table. All right, 16. If y is that, then what is the derivative at 3? Product rule. First d second plus second d first. How do you take the derivative of a radical? Do you remember the shortcut? Derivative of a radical, rather than change it to something to the 1/2, you double it on the bottom, derivative of the inside part on the top. It makes it a whole lot easier to deal with square roots when you do that. Remember, double the radical on the bottom, derivative of the inside part on the top. 2's just happen to cancel. Then I plug a 3 in. And remember, label it like this. This was 8 years ago. That's a little sloppy on my part. It would be better to say the derivative at x equals 3. Usually the only time you put a value down there is if it's a point. You can just put the whole point down there. It's better to say x equals 3. And then just clean it all up. And notice they didn't rationalize jack. You probably don't have to. So that idea that you have to rationalize, that we cruelly brainwashed you into over the past couple of years, don't do that initially. Look at your answers first. All right, number 17, the limit of that. I'm hoping that when you look at that, you go, oh, definition of a derivative. Anybody see that? A couple of y'all? If you see a something plus h, you're like, oh, wait a minute, this is like f of x plus h. So what was my function? Arc sine. And if I know my function's arc sine, rather than take the derivative with the limit definition, I can just take the derivative with my derivative definition, which many of you don't know based on the test I just gave. You guys did better than the other class, and a lot of you did know it, but if you just know that derivative, which says 1 minus whatever that is squared, and then the derivative of whatever you have here on the top, right? So the square root of 1 minus whatever that is squared, derivative of that on the top, and then all I got to do is plug in my a value, which is 2. I'm sorry, not plug it in. This is the derivative. The derivative is equal to 2. So this actually took it a little bit further with the algebra. So if the derivative is 2, then once I have your derivative equation, set it equal to 2, and then just solve the algebra. So once I set it equal to 2, I squared both sides to get to here, and I cross multiply and solve for a. So a little bit ugly, and it says which could be a value. Either one of those could have been a value. Positive was an option. So I thought that was a little tricky because it had a little bit extra algebra, and that does occur occasionally. And you can see they're kind of stepping up their game as they near 25 or 27, whatever, 20. Number 18, if the natural log of that is this, what is the derivative? Well, again, this now applies what? When you have x's and y's all mixed up, implicit differentiation. So how do I take the derivative of a natural log? Copy the junk to the bottom, and then what? The derivative of that junk on the top. So if I copy the 2x plus y to the bottom, the derivative of that is 2 plus 1 dy dx on the top. The derivative of x plus 1 is just 1 plus nothing. And at this point, I want to know what dy dx is, so I cross multiply and subtracted 2. You with me? And there's other ways to do that too that we've not spoken of, but that's probably the easiest way. 19 says the figure shows the graph of g and the line tangent to the graph of g at -1. Let h be this function. What's the derivative of h at -1? Again, they're just messing with you at this point. Well, how do I find the derivative of h if h is that? Product rule. First, d second plus second d first. And the derivative at -1, I plug a -1 in. Now, sometimes e to the -1 is 1 over e. That part wasn't bad. But the other parts I had to use the table for. The picture for. So I had to find the slope of g at -1 and g of -1. So what's g of -1? 3. What's the slope of g at -1? Well, they gave you this, didn't they? So I can go y minus y over x minus x, and I get, what, -6? So I plug the 3 and the -6 in there, and then I just clean it up if I have to. Not uncommon for this kind of stuff to happen. Does that throw y'all off? Are y'all tracking with me? Where they intertwine a function with a graph and ask you to make sure you understand the processes? All right, 20 says if d dx of that, it says for all values of x, this is just a simple example of what? Number 20. Second fundamental theorem. So second fundamental theorem, if you have a d dx of an integral, it cancels, ignore the 0, but you got to be careful to do what? Not only plug the 2x in, but also take the derivative of the 2x, which is times 2. That's the stuff that everybody forgets. A lot of people like to pick b. If you picked b, you forgot to go times 2. It's really the d. And we're down to 2 minutes for it. Hey, we're going to have more time tomorrow because it's a smaller section to go over in class. I think we'll have more time, but I'll hand you that thing in 2 seconds. Number 25, and we'll come back and, what did we just finish? 20, so we'll come back and pick up with 21. Here's number 25. 24. So which of the following is the solution to that differential equation? So I did this. E to the y plus x is the same thing as e to the y times e to the x. I had to separate that out so that I can separate my variables. You all know that that's true?
Yeah.
Right here? If you didn't know that, I know I talked about some of that in math in class. Then I can slide the e to the y down, slide the dx up, take the integral of both sides. You're going to have to do a u substitution here, which puts a negative out front. This integrates pretty nicely. And at that point, I'm going to multiply both sides by a negative, which gets the negative over here on the right, and the c eats the negative. And then I'm going to natural log both sides to get rid of that e. And then the last step is I'm going to multiply both sides by, oh, no, I wanted to solve for c. I chose to solve for c there. So I plugged a 0 in for x and a natural log of 4 in for y, and a negative ln 4 in for y. But notice I should have said this. I should have said at 0, negative ln 4, and showed that step. Show that so that the reader will be able to see what you're doing. And then I solved for c and plugged it back in. Hey guys, make sure you grab one of these on the way out. This is your homework for tonight. And remember, I'm not going to give you a ton of homework, but when I do, please don't take the night off. All right? If you haven't done A, maybe go back and get some practice. Yep. That's just tonight. Yeah. Got it? Got it? Anybody going to see Daniel?
Yeah. She's gonna be.
Anybody got one?
She's-
Everybody's got one?
You trying to steal like
No, it's fine. I have some in mind.
Okay. I would get you one.
See you.